In today's video, we will see what is random variable and random process. So random variable, we know that random variable maps sample points to the real numbers. Suppose you do one experiment, that is a random experiment whose output is unknown, or it is a random output of that experiment is random. That's why it is called random experiment. So let us consider one experiment of tossing two fair coins simultaneously. In that case, you will get the outcomes or sample points as TT, TH, HT, TH, and HH. Suppose you have to map these values to the real numbers, then you have to define the random variable x. Random variable, here notation we are using as x, and its definition is count the number of heads in the outcome. So the number of heads in the first outcome is 0, in second it is 1, it is in third it is 1, and in fourth it is 2. So thus the random variable should have some definition, then only it could map the variable outcomes of the sample space to the real numbers as well. It should have some notation. So here the notation is capital X. Now let us see what is random process. Because in this video we are going to have the link between random variable and random process. So if this experiment, whatever the experiment we have just stated, that tossing two fair coins, if you do that experiment at different at different instants of time, that means that random variable then becomes the function of the time. So if you do such a experiment at different instants of time in a day, then you will get some waveform like this at one day at different instance. That means at from 7 a.m. if you start, then from 7 a.m. to up to 7 p.m. if you do, then you will get the waveform like this, where you will get these small points are nothing but the sample point. That means you will get either 0 0, either 0 1 2. That means you will either get TT, HT, TH, or HH. So you will get the random variable values as a function of time. So this waveform is called sample function. If you perform this experiment on another day, you will get another waveform, that is called sample function 2. If you collect such waveforms, such sample functions, then this collection is called the random process. So this collection of these x1 to so this collection of sample functions is nothing but the random process. Now this collection is also called ensemble. Many times it is called ensemble. So here I want to tell you some important points, that you if you observe, these points are nothing but the sample points. That means these are TT, HT, TH, HH. These are also the sample points. That means we can say that in the random process there are infinite number of sample points. And another important point is that if you fix the time t, here if you fix the time t1 and take the values of x1t at t1, x2t at t1, xkt at t1, then you will get what? You will get sample points only, but you will get the bunch or group of sample points. Then that becomes the random variable. So this collection is nothing but the random variable. So if you take at different instants of time, you will get the random variables. That means we can say that random process is this random process also contains infinite number of random variables. So these two points are important, that random process contains infinite number of sample points as well as infinite number of random variables. Now let us see what is analogy between random variable and random process. We know that random variable is collection of the sample points. How it is collection of sample points? Because it is the random variable here, so it is collection of sample points only, which are mapped sample points. It is collection of mapped sample points. That means it contains the real values for the sample points. Now what is the random process? Random process is collection of the sample functions. What is sample function? It is nothing but the random variable at different instant of times. It is the sample function. Next, a random variable maps the sample points to the real numbers, and random process maps the sample points to the sample function. So here in the random variable there is concept of the sample space. it is collection of the sample points. And in the random process there is concept of the ensemble, which is collection of the sample function. So with this video I will I have created the link between the random variable and random process.